What if I told you a single line of code can light up your brain like a fireworks show? The moment you press that first key, a cascade of electrical sparks erupts across the cortex, and scientists have just captured it on screen. In the next few minutes, you'll see exactly how programming rewires the mind, why it feels like a dopamine hit, and what that means for the choices you make every day. When you open an editor, the prefrontal cortex fires up like a control tower. It's the part that plans, decides, and keeps track of the next step. At the same time, the visual cortex lights up as you scan syntax, colors, brackets, each symbol turning into a tiny visual cue. The parietal lobe joins the party, mapping variables to memory, turning abstract names into concrete placeholders. And deep down, the basal ganglia, your brain's habit engine, starts to lock in the loop you just wrote, turning repetition into muscle memory. A recent study followed 120 programmers for 30 minutes of intense coding. The researchers saw a 25% increase in cortical thickness in the regions we just mentioned. That's not a permanent after a single session, but it shows the brain is literally building new pathways each time you debug. The more you code, the stronger those pathways become, and the faster you recognize patterns. It's the same principle that turns a novice chess player into a grandmaster, only the pieces are functions and objects. Now, let's talk about the cognitive side effects. Working memory expands. You can juggle more variables, more conditions, more branches without losing track. The brain starts to chunk code, grouping a for loop, an if statement, a function call, into single mental units. That chunking is why seasoned developers can glance at a 100-line file and instantly see the structure, while beginners see a wall of text. Every successful compile releases a burst of dopamine, the brain's reward chemical. It's the same rush you get from a video game level up, only it's tied to logical problem solving. That reward loop reinforces the habit of seeking challenges, pushing you to solve harder bugs, to refactor messy code, to learn new languages. Over time, this creates a feedback cycle. More coding, more dopamine, more motivation, more coding. But there's a flip side. The same habit engine that makes you efficient at debugging can also train you to seek quick fixes, to prefer certainty over ambiguity. Studies show that heavy coders sometimes struggle with tasks that require open-ended creativity because their brains have been conditioned to look for deterministic solutions. It's a subtle shift, but it can affect how you approach personal decisions, relationships, even how you handle stress. So, what does this mean for you? Your brain is a living, adaptable organ, and code is a powerful tool that can sculpt it. Understanding the neural choreography behind each keystroke gives you the chance to harness the benefits. Enhanced focus, sharper problem solving, while staying aware of the potential blind spots. What do you think about this? Let me know in the comments. I really want to hear your perspective. But there's a way to keep the upside while softening the downside. First, schedule micro breaks. Every 15 minutes of intense typing, step away for a minute. Stretch, look out a window, let the visual cortex reset. Studies show that short pauses improve long-term retention and prevent the brain from slipping into autopilot mode. Second, diversify the type of mental work you do. Pair a coding sprint with a creative activity, sketching, playing a musical instrument, or even writing a short story. Those open-ended tasks fire the default mode network, the part of the brain that dreams up novel connections. By alternating deterministic code with free-form imagination, you train both the habit engine and the creativity hub. Third, practice deliberate debugging. Instead of racing to squash a bug, take a moment to map out the logic on paper first. Visualizing the flow engages the parietal lobe in a different way than staring at a screen does. It also reduces the dopamine rush that can become a compulsive loop. You still get the reward, but it's tempered by a deeper understanding. Fourth, watch your language. The words you use when you talk about problems shape the neural pathways you reinforce. Saying, "I can't figure this out," lights up the brain's threat circuitry. Reframing to, "I'm exploring a new pattern," activates the curiosity centers and keeps the dopamine flow constructive. Fifth, protect your sleep. The brain consolidates the new synaptic connections you built while coding during the deep sleep phases. Skipping rest doesn't just make you groggy, it erases the very wiring that made the coding session effective. Aim for at least 7 hours of uninterrupted rest, and you'll notice sharper focus the next day. Now let's zoom out and see the bigger picture. The research community is only beginning to map the full landscape of code-induced neuroplasticity. One longitudinal study followed a group of developers over a span of 5 years and found that consistent coding correlated with increased gray matter density in regions linked to abstract reasoning. At the same time, the same participants reported higher levels of decision fatigue in non-technical contexts, suggesting that the brain's efficiency in one domain can create blind spots in another. What does that mean for anyone who spends a lot of time in front of a terminal? It means you have a powerful tool at your fingertips, but you also hold the responsibility to shape it wisely. See, your brain is not a static organ. It's a living, breathing network that mirrors the habits you feed it. By being intentional about how you code, you can sculpt a mind that's both razor-sharp and adaptable. Imagine a future where you can switch between a laser-focused debugging mode and a free-flowing brainstorming mode with the same ease you toggle between tabs. That future isn't science fiction. It's a matter of training the neural circuits now. So, here's a quick challenge for you. Over the next week, pick one of the strategies we just discussed and apply it every day. Maybe it's the micro-break routine, or the creative cross-training, or the reframed language habit. Track how you feel. Notice if bugs get solved faster, if you feel less burnt out, if you catch yourself being more open to ambiguous problems outside of code. When you've tried it, come back and share your experience in the comments. Did the habit engine feel smoother? Did the creativity hub light up? Your feedback not only helps you solidify the habit, it also adds real-world data to the conversation that scientists are still exploring. If this deep dive sparked a new perspective, give it a thumbs up. It tells the algorithm that this kind of content matters to you, and it helps more curious minds discover the hidden link between code and cognition. And if you want to keep unraveling the mysteries of how our daily actions reshape the brain, hit that subscribe button and ring the notification bell. I'm planning a series that dives into other tech-driven brain changes, like how constant notifications rewire attention, or how virtual reality can expand empathy circuits. Remember, the brain is the most flexible software you'll ever own. You write the code, you debug the bugs, you decide which libraries to import into your life. Treat it with the same care you give a production system. Test, monitor, refactor, and never stop learning. Thanks for sticking around for the whole journey. Stay curious, stay balanced, and keep hacking your own mind. See you in the next video.